This is slide number 9. So we establish inventory with these 4 string items. If we call pop without any index value, it pops off the last one. On the other hand, we can, let's do these one at a time. Let's do this. So set inventory up. So take a look at what inventory looks like now. Looks like this. Then we're going to pop off the last one, but I won't assign it to anything. Inventory.pop, like this. Notice that pop actually does 2 things. It removed the last item from the list forever. You can verify that by saying, show me inventory, but it also returns the value. Not all methods will do that, okay, but pop does. Or we could say, for example, inventory pop 1. Oops. Notice we're enclosing the index in parentheses, not in brackets. And that popped off the second item, which has an index of 1. And again, inventory is permanently changed. Okay. So some of these methods that we will look at today will permanently change the original item and others don't. And some of these methods are silent in that they don't really return any value. They just do something to the list. But others like pop do return a value. So you got to keep track of that. The index method is looking for a name, a value, right? So the index method, you will look for a match on the value and will return the index number. Okay, so that's what this slide is doing. Now, length, len, which is a function similar to R also has an len function, returns the length. So it just tells you how many items are in the list. And another thing about length, right? Length starts counting at 1. It has nothing to do with the indexes. It's just counting the actual number of items. So even though the first item, if you have 6 items in a list, the last item will have an index of 5, but if you apply length to that, it will return 6 because there's 6 items. Okay, so what are we doing here? Here we're using the in keyword to search for an item in the list. And this will remove the item, right? So if we establish a variable called item and give it a value, if there is an item in the list that has that particular value, when we run this, it should remove it. And let's see, this is slide number 12. Let's see if this works. So I embellished that slide a little bit so we can see what's going on. We establish inventory and then we print it out. And we're looking for bread, and we use the in keyword with an if statement to find it and then to remove it. Okay, so let's see if it works. And so it did. This was inventory, the inventory list that we started out with. It had 4 items. We searched for bread and we removed it from the list like that. Okay. And this example just simply demonstrates the use of the print function. You actually don't have to say print. You can just say the name of the variable. Let's see if we still have inventory there. So here's the inventory as it currently exists in memory. In fact, when you name the variable, like I did here, it calls the print function. It looks for the value of the variable, and then it calls the print function to show it to you, right? So print is redundant. You really don't have to use it. And since most programmers want to get things done with as few keystrokes as possible, many won't use print at all. Okay, so let's look at the syntax for looping through a list. And we can process all items in the list like this. Now, here's the general syntax up here. If I'm not mistaken, however, you don't have to use, this can be anything. You can use any variable, any valid variable name that you want here. We're using item just because it's descriptive of what we're looking for. So let's run this. Right, so this will just simply print out the items that are in inventory. But notice instead of item, I'm just saying thing. These two have to match, of course. This is just a normal old for statement, so you have to include the colon, and then in the block, the indented block, you have to match the variable name that you have up here. So this just simply shows you, it doesn't have to be item, it can be anything that you want. Okay, so again, this is just a for loop that's executed once for each item in the list. Okay. And similar to what you can do with a for loop, you can do it with a while loop as well. Again, in this first example, we just set up a list of scores, and we initialized a variable called total to 0. And then we loop through each score in the scores list, and we add it to the total using this incremental assignment operator, right? So it simply will print them all out. We can do the same thing with a while loop, but in the case of a while loop, you would have to have some sort of a counter. Okay, so we set up the counter to 0, and we walk through the list up to the length, up to the total number of items that are in the list, and we retrieve each value for scores based on that index, and print it and add it to the total. Okay, so these two loops do the same thing. You do not need to use an index to get each item. You don't need to use a counter variable, but you don't need to know the length, but you do need to know the length of the list. Okay. So here's some more functions. Now these are more concise. I find them a bit confusing. And again, they're new. They're new to me, new to Python as far as I know. So these are built-in functions for processing list items instead of walking through them with loops. Enumerate, let's see, what does enumerate do? Enumerate, we pass to it the list, and we pass an optional start argument that allows you to set the initial value of the counter, and enumerate adds a counter to each item in the list. The optional start argument allows you to set the initial value. We'll take a look at an example shortly, I believe. With zip, zip will accept a variable number of lists and returns the value of the current item in each list. Okay, so these are built-in functions that you can use to process the items in a list. You can use enumerate when you want to associate a counter value with the items in the list. You can use the zip function when you want to process two or more lists in parallel. Well, what does that mean? Okay, each of these three little pieces of code do the exact same thing. We are getting a counter value when processing the items in the list. Here, let's run it and then talk about it. And let's see, I added some print statements. No, this is the same. So let's run it. Each one should do the same thing. And they do. They simply walk through the list and print each item. Now, enumerate, which is the last one, is more concise. Okay, I have these print lines in here just simply to add a space between them, but with the for loop, we've got 3 lines. In this first for loop, we have 3 lines. In this one, using length, we also have 3 lines. But enumerate is again more compact and more succinct, I guess. So it's a matter of preference. I would probably prefer to use a for loop, but enumerate, really, you're going to get more traction using enumerate because it is more powerful and more concise. Okay, so with enumerate, you don't need to increment a counter variable, and you don't need to use the range function like we did up here to get the index for each item. In addition, with enumerate, you can use this optional start argument of the function to set the initial value of the counter, which defaults to 0. Here we're setting it equal to 1. Okay, so that's that. And this is what all 3 of them return. Okay, zip, on the other hand, is useful for processing 2 lists in parallel. And so we've set up 2 different lists, right? Inventory, which has the string names, and prices, which has the real numbers that are costs associated with each of the items, the string names. And so we just say for item and price in zip, and then we call both of the lists. And note, let's run this and see if it works. Slide 19. Right, so we're starting with these 2 lists, but notice what the output looks like. Yeah, the output looks pretty, and we formatted dollars and cents. How did we do that? Well, we didn't call any locale module, that's for sure. We just simply did it manually with an F statement, right? So the string in the F statement, which starts here and ends here, any sort of character that we put in there other than a backslash, which is a special, an escape character, will be printed literally. Okay, so it is literally printing these parentheses with the $, which makes it look nice when it comes out.